All right, next up on our study of waves and light, we are going to talk about quantum theory. So, quantum theory, who's the biggest, most important player here? That'll be Planck. In 1900, he made an observation. He observed that hot objects emit light, right? You guys have probably seen this before. If a metal object gets really, really hot, it glows. It emits light from itself. From this observation, he concluded that energy is emitted in small, specific amounts. And he called those energy amounts quanta. That's plural. So quantum, this is the minimum amount of energy changed. So when energy is released in the form of light, it is releasing it in a quantum. Okay, so before Planck's theory, there was the classical theory of that energy release, and that it was like a slow, progressive energy release. But Planck revolutionized that and said, no, 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 that's not right. Actually, it is more like leaps. Okay, so once there is enough energy to be released, it releases this packet of energy, this quantum of energy. Okay, Einstein, also very important. Just a few years later in 1905, Einstein observed the photoelectric effect. And what this is that when an object, particularly metal objects were being studied here, is exposed to the electromagnetic radiation, so that EM spectrum, that energy is released from that object, particularly charged particles. So, from Einstein's observation, he concluded that light has properties of both waves and particles. Okay, so light is particles that move in waves. He called this the wave-particle duality. And also discovered the photon. So a photon is a particle of light that carries a quantum of energy. Okay, so Einstein built on Planck. Okay, and we can calculate that energy. Okay, so let's get out our equation sheet so we can add this equation to it. Okay, because it turns out that energy of a photon is proportional to its frequency. Okay, so the equation is E equals hv. E stands for energy, and that's going to be measured in joules. And just so you know, joules is one of those derived units so that we can help maintain units as we are solving problems. A joule is kilograms meter squared per second squared. Okay, so big derived unit there. Okay, H stands for Planck's constant. So this is another one of those constants, one of those numbers that's never going to change. So H is always this number. Okay, 6.6262 times 10 to the negative 34th joules second. Okay, remember that joules is actually really this. Okay. And then V, just like it did in our last equation, stands for frequency. Frequency can be measured in hertz. Remember, hertz is the same thing as per second. Okay, so you can see as you go to work through this equation, if you are solving for E, you have joules second per second, which is the same thing as this. If you are solving for H, you can see that the per second cancels off and leaves you. You can see if, so that's going to help you by knowing how to write all of this out. Okay, this is another equation that we can use our handy dandy triangle for. So E will go on top, H and V go on the bottom because H times V. And then that way, if you know one, you know what you need to do to figure out the others. Helps you rearrange that equation for you. So let's do a practice problem. All right, find the energy of a red photon with a frequency of 4.57 times 10 to the 14th hertz. So like always, let's figure out what information do we know. Okay, well, first off it says find the energy. So I know I'm looking for what is E. Okay, and it says the frequency of, so my V is this. Okay, so then I look at my equation sheet, I see, okay, what equation has an E and a V in it? And I know that it is my energy equation, and so I know what H is, because that's a constant. H is always the same. Okay? Then I just plug in my numbers. So use that original equation, E equals HV. Don't even need a triangle this time because it's H times V. And I just plug this into my calculator. Okay, remember when typing into the calculator, make sure you have a calculator that understands how to do this function. So make sure you have a scientific calculator that allows you to do the exponents. So it has that EE button like we've been using throughout the semester. And we will get our answer. So you see we have joules second here, we have per second here, so those two will cancel out and we will be left with joules. And if we look at our equation sheet, we see that an expected outcome is joules, so that's good. Okay, why is my answer 3.03 times 10 to the negative 19th? If I go back up to my problem, the only answer I was given here has 3 sig figs. The only number that I was given, which means that my answer should have 3 sig figs. Okay? If you are not able to get this answer when you are working it out, get into contact with me so I can try to figure out and help you make sure we can get you on the right track.